So, we are going to start the class on nanotechnology in chemical engineering. So, in this today lecture, so we will discuss about the characterizations, various characterization techniques are available. So, once we synthesize nanostructure materials, how we can characterize them, and then applications of those materials. So, not more details, just what are the various chemical engineering aspects. So, that applications are available. So, where we prepared whatever the nanomaterials, so that we can apply a specific application. So, that we will discuss. Okay. So, in the previous class we have discussed about synthesis of nanomaterials. So, once we have prepared a particular nanomaterials, so then we have to characterize them. So, to once we know their characteristics, characteristics means of what type of materials that we have prepared. So, it is what would be a dimensions of that nanomaterials, either it is 5 nanometer, 10 nanometer, 20 nanometers, or it is cylindrical shapes or cubical shapes, spherical shapes, depending upon that material characterizations. So, that particular property will be developed, and then we can get a desired results or different results. So, now what are the characterization techniques are available to characterize those nanomaterials, and then applications, these are the things we will discuss. So, now let us start about the characterizations techniques, what are the characterization techniques available. So, actually once we prepared a materials, then our next objective is to develop a correlations with the structure, shape and chemical composition of the nanomaterials. Okay. So, once this property means size, I said crystalline structure, compositions, thermals, behaviors, chemical state, optical properties, magnetic properties, mechanical properties. These are the properties whatever we have discussed in our previous class. So, that are important. Okay. So, whatever the nanomaterials that we are prepared, that may be in form of colloid or maybe particles, it may be films. Okay. So, that particles, whatever the materials, that informations or characterizations is important. Okay. So, now there are many methods are available. One is we can say imaging methods, and another one is analytical techniques. So, imaging methods, that is basically we can use microscope. So, different type of microscopes are available, so that we can use to characterize that materials. And second analytical technique, that is spectroscopic techniques, that we can use to characterize our synthesized nanomaterials. So, in microscopic techniques there are scanning near field optical microscope or SNOM, that we can use SEM, TEM, we can use STM or scanning tunneling microscopes or AFMs. So, these are the characterizations microscopic technique we can use. This particulars, and suppose we have a thin films we have developed over a particular surface or applications. So, if you want to check that whether there is any cracks, agglomerations over the surface of that particular thin films what we have developed, so that we can characterize, or maybe we can morphological structure, size, compositions, these we can characterize using this microscopic technique. So, next is the spectroscopic techniques, particularly UV NIR spectroscopic observations technology, that we can solid material by DRS method, diffuse reflectance spectroscopy, or this IRs. So, we can these instruments we can use UV NIR spectrophotometers we can say, that is. So, we can use, or FTR we can use Raman spectroscopy, XPS, atomic absorption spectroscopy, EPR, NMRs, AES, Auger electron spectroscopy, that we can use particular whatever the materials we have prepared. This spectroscopic technique is useful for to check bonding, charge transfer among atoms or electronic structures, that we can find out or detect. Next is diffraction techniques, that is also XRD we can use to find out the materials property. DLS we can use also, and then electrical and magnetic properties of that materials. For that we can use squid measurement, optical measurements, that we can use, or mechanical property, whatever the Young modulus, stress, strain, strength, hardness, these are the things we can measure, or we can elastic moduli, that or nano indentation methods that we can use to that particular property. Okay. So, here nano characterization and nanoscale characterizations way we have classified, or we can divided whatever the total characterization techniques we have. So, here nanomaterials characterizations means BT, TGA, DTD, FTIR Ramons we can use, and if nanoscale characterization, then these are the characterizations techniques, imaging techniques we can use. Okay. So, now each particular methods and its purpose of characterizations. So, whatever the nanofilms, nanomaterials, nanoparticles, whatever we develops with the TEM, we can get surface morphology. With the PLs, the electronic energy and energy excitations that we can means identify, and then UVs I said band gap or absorptions of that particular materials we can find out, and then using same ACM image. So, we can surface morphology, size or nanoparticle formations. Like this particular method is very useful when we have developed some carbon nanotubes, its diameter, dimensions, length measurements we can use. Energy dispersive methods, nanoparticle compositions analysis we can do using EDS, energy dispersive spectroscopy, that is with same it is available. XPS also we can use to elemental compositions and chemical state of, suppose we have a catalyst or materials nanoparticles that is made of copper. So, that copper may be two different oxidation state +1 +2. So, and what ratio that are present, that also we can find out. Similarly, FTIR is there, functional groups are present that we can characterize, exadic, degree of crystallinity, zeta potential, that is very useful. Whence we have a liquid nanoparticles in liquids, liquid colloids formations, there the stability of that nanoparticle in that colloids. So, using zeta potentials we can find out, and then wavelength dispersive X-ray spectrometry, that also we can use to know the elemental compositions in that metals nanoparticles. XRFs we can use, also AFM, that is useful whenever the nanofilms we have formed. So, then topographical image in 3D structure, so that is we can able to get, and then Raman spectroscopy, that would be useful for metal oxides or any carbon nanotubes, other materials whatever we prepare. So, that vibrations characterizations of that particular materials we can characterize, and then NMRs also, structure and chemical bonding, AES agar electron spectroscopy for chemical state and bonding. So, that nanoparticles having, so that we can find out, and then thermogravimetry analysis. So, that is TGA, DTG or DT analysis, the thermal stability and decomposition of a particular nanomaterial. Suppose we have prepared a MOF material, so that stability of that materials, if we heat it up low temperature to the high temperatures, that would decompose, or maybe let us say depositions of carbon nanotubes or element carbons of the catalyst surface or nanomaterial surface. So, if we heat it up or oxidized, then that would be oxidized at a particular temperature by using TGA analysis. The amount of quantification also we can do, how much quantity that have been deposited over the surface of that material. Then fluorescence emission spectrum, that using validate the UV results whatever we get. So, now applications, these are the various characterization techniques. So, individual characterization technique or group of characterizations we will discuss in later more details. So, that would be useful for us, and then now is the applications. So, once we know prepared a nanomaterials, we have characterized that materials, and then application, that is very important. And here whatever the nanomaterials we have prepared, we application that would be totally based on chemical engineering aspect. There are nanomaterials whatever we are preparing, that may be wide applications, many way, electronics, electricals, many applications are there. So, biological applications, but all is not possible to discuss. So, only from chemical point of view, what are the place we can use those materials, so that we will discuss. So, today we will just give a preliminary idea individual applications, and then more details individual applications we will discuss more details. Okay. So, here I am showing a list of applications chemical engineering oriented. So, that is heat transfer as a thermal fluids or coolants we can use, that nano fluids or nanomaterials in that thermal fluids whatever used in heat exchangers. So, there we can use nanomaterials. Then mass transfer, where as a nanofluid we can prepare using nanomaterials. Then CO2 separations or any other oxygen, ammonia, any gas components that is present in a gas mixtures, that we can separate out with the help of mass transfer equipments. So, there the nanotechnology is applicable. Next is photocatalysis or catalysis reactions, where nanomaterials we can synthesize and that we can apply to convert a target product reactant into a target products by using catalyst. That catalyst will be prepared in having nano structures and nano metal oxide that would be deposited above the surface of that substrate or support material. So, by that way, if you are able to develop more and more nano range that particles and that use that materials in catalytic reactions, then we can get more or higher conversions, that is good. Okay. And next is wastewater treatment. So, in wastewater there are lot of pollutants are available, so present. So, that we want to microorganism, bacteria, virus present. So, if you want to degrade them and get a clean water, so then nanotechnology or nanomaterials, whatever specific materials we can use to for that particular wastewater to clean water treatment, clean waters. And then nitrogen fuel cells, biofuel productions. So, if we have a lot of biomass, bio waste available. So, if you want to convert that bio waste into useful biofuel or synthetic fuel, that may be hydrogens, natural gas, synthetic natural gas or ethanol, methanol, many things we can produce using raw biomass. There we can put some nanomaterials and then we can get our desired product, maybe hydrogens or syngas productions we can get. Next is hydrogen storage. So, now when we are shifting from conventional fuel, crude oil, diesel, petrol to hydrogens as a source of energy, then hydrogen storage a particular is a challenge. It means if we want to store hydrogens and then whenever it is required, then we can get by using some catalyst or other things. So, nanomaterials, if you want to store in case of liquid, solid or gas phase, that is density is very low. So, in solid phase materials we can use. So, that materials we can change its property by using nanomaterials, and there is a target amount of hydrogens that we can store there by modifying that surface of that material. So, that is the application. Then enhance oils recovery, means oil and petroleum industry, where crude oil that has been taken out from that rig or whatever that place underground present. So, from there we can collect that oils by using different nanomaterials, that has a lot of application that we will discuss. And then polymer or nanocomposite preparation. So, nanocomposite polymers, I think there are a lot of applications or places where nano means materials we can use with the polymers. So, then nanocomposite you can prepare and that would be useful for membrane reactors or maybe that in wastewater treatments, many places this polymeric nanocomposite are useful. So, okay. So, next step, the nanotechnology heat transfer. I said thermal fluids we can use, it improve the heat transfer performance. Suppose we have prepared a nanomaterials and that we are using with the base fluids. So, prepare nanofluids that is useful or improve the heat transfer performance in automobile industry as a cooling systems to improve its heat transfer performance. By that way we can operate the engines and at optimum temperatures. At the same times, the if heat once have using the nanofluids in a particular vehicles, then the heat transfer coefficients would be better. As a result, we can down the weight of that vehicle systems by getting a better heat transfer systems that can provide to cool down the engine. So, this is heat transfer. Another one is the mass transfer. So, mass transfer I said. So, many nanomaterials we can use prepared that can use for, that is zeolite, CNT, MOF, graphene. So, we can use for CO2 absorptions. Okay. So, by many way membrane separation, absorptions, cryogenic process, many way we can separate them out. Means once we use that nanomaterial with a particular specific fluids, then absorptions capability that will improve. Means if you want to separate out CO2 from a gas mixture, so then by using this type of nanomaterials, so that would help, means performance of that mass transfer operations will improve. So later we will discuss more details. So next, catalysis, I said different type of catalyst we can prepare, that is metal oxide materials, nano composite we can prepare, and that we can use hydrocarbon processings, renewable energy biomass conversions, fuel cells and fine chemicals synthesis. Many places we can use these nanomaterials. Okay. So catalytic activity will improve, as a result we can get more conversions, more product that we can use. And then environmental remediations, I said. So this wastewater treatment, so there also we can, means suppose we have a calcium peroxides that we want to remove as a biopollutant, or a calcium oxide peroxide that we can use once we have a biopollutants that we can remove. Iron based nanoparticles remove, arsenic if it is available in soils that we can remove, and dendrimers that we can use for removal of heavy metals, titanium we can use for wastewater treatments, and zero valent ions that we can use for removal of organic contaminants, and to removal of PHA pollutants. So micelles we can use, and nanoparticle bimetal nanoparticles that also we can use for if specific reactions we can use. So here also you can see different organic pollutants, inorganic pollutants, microorganisms if it is available. So we can use different type of nanoparticles, metal oxides, bimetallic, modifieds or biocomposite or clay type of clay nano composites that we can use specific applications, dye degradations or any metal separations or bacteria or microorganism if we want to kill. So then we can use a specific nanomaterials depending on applications. Next is the microbial fuel cells. So in fuel cells we can use electrodes, so cathode and anode. So if we modified that electrodes with the using various type of nanomaterials, so then performance of that electrode or fuel cells will improve. So here usually traditional jo films whatever that films, nanofilms, Nafion or Ultrex that we can use PM, proton exchange membrane that is in the fuel cells, that if we modify with multiple nanotubes titania, so then performance will improve of these membranes. Okay. Similarly, whatever the anode materials we are using, so anode materials if we modified with the CNT or cathode materials that we modified with the, this is cathode, this is anode. So if we modify both of them, cathode, anodes and membranes with the nanomaterials, so then overall performance will be enhanced. Okay. So organic pollutant conversions, we can use this type of modified electrodes, membranes to improve the performance of the microbial fuel cells. So then wastewater treatment, I said. So in wastewater treatment, so there also in wastewater many components are present. So when wastewater raw water is coming, so it is presents so many suspended particles, oil emulsion, bacteria cells. So if we use this type of nanomaterials, valent iron, titanium and membrane is there, membranes will be modified as CNT modified membranes, nanoparticles modified membranes that we can use, and then that would, when it is passed through this process, so then after that we can remove, we can kill them, filter them out, and then we can get treated waters. Okay. So here many contaminants, organic based nanoparticle, inorganic based nanoparticles or polymer based nanoparticles that we can use to separate out heavy metals, okay, pathogens or different microorganisms. So that already have discussed for wastewater treatment. So fuel cells are fuel and microbial fuel cells. So similar type of that. So here also we can use electrodes, that electrode would be modified, and then biofuel productions. I said we have abundance of wood chips, animal waste, crops residue, pellets. These are the biomaterials or biomass we have available. So, those biomass we are not using, throwing out. So, we can use those biomass and convert them into useful fuel, biofuel, that is by using nanomaterials. If we use nanomaterials, metal oxides, nanomaterials, nanoparticles, so that would be converted into a hydrogen, biohydrogens, biodiesel, bioethanols using nanoparticles. So, these are the nanomaterials I said. So, depending upon applications and performance, particular materials, CNT or magnetic nanomaterials or metal oxides we can use, bimetals, more than 2 metals also, metal oxides we can use for transformations of biomaterials into biogas, bioethanols, biohydrogens, biodiesel transformations. Okay, so then hydrogen storage also I said. So, in hydrogen storage usually it has been observed that if we use single one nanotubes materials, it can store 0.63% of hydrogens at 45 bar at room temperature. That is very small quantity of hydrogens, not very good quantity of hydrogens. So, here if you see CNT with lithium or sodium doped, so that can store 14 to 28% at 400 degree centigrade room temperature, that can absorb. So, it is reported, but this data we have to check. And so, in BnCNT, boron nitride CNT, boron nitride that was modified with the CNT, then it can store 4.28% of hydrogens at room temperature. So, that is also good amount. Then silicon carbide, carbon nanoscrolls, pillared graphenes, these are the materials also we can use to store hydrogens. Okay, so, these are the nanomaterials. So, we can use to store hydrogens at room temperature or low temperature conditions. Okay. Porous nanotube network also, this type of, actually this is deep theoretical study that have been done, and this type of structures they have developed by simulation. Okay, simulation study they have means developed those type of structures of that materials. Okay. So, these are the various nanomaterials I said. So, nanoparticles. So, we can use irons doped in magnesium hydrides, that is hydrogen storage materials, there we can use, and nickel doped MgH2 or graphenes and 5-8% titanium carbons that can use to catalyze sodium aluminum hydride. This is actually hydrogen storage materials. If you want to MgH2 sodium aluminum hydrides, these are lithium aluminum hydrides. There are so many materials available, sodium borohydrides. These are the hydrogen storage materials. So, solid phase hydrogens we can store. So, with these materials, so if we use some nanomaterials or nanoparticles, that may be different metal oxides I said, nanoparticles. So, we can use it here. Okay. So, then absorption desorptions of these hydrogens will improve. Okay. So, depending upon that application or performance study, so we can get a particular materials is useful. Means oil explorations also, means hydrocarbon explorations, reservoir, they are drilling, cementing, this process are going on, or and there we can use these nanomaterials or nanotechnology we can use. Okay. And enhanced oil recovery I said, for enhanced oil recovery from the whence oil is present in rig. So, there's we can pass the nanofluids. So, here you can see a structure, say undergrounds, there this is oil is present, this black one is oils, and this green one, that is the nanofluids we can pass, and then these nanomaterials, this is nanoparticles. So, that can forms nano emulsion, that type of structure formations is there. So, that more details means how this nanotechnology is useful, or nanofluids, nanomaterials to oil recovery from the rig. So, that we discuss. Actually, there is oil phase and aqueous phase is present in the rigs, and there's when we use some nanomaterials. So, it would reduce the interfacial tension in between soil and water phase, and therefore, the oil recovery would be faster. Okay. So, by that way we can get more oil recovered from that rig. So, by using these nanomaterials or different type of nanomaterials we can use. So, here type of nanomaterials is showing. Okay, so next is polymeric nanocomposite also I said. So, suppose we have a different type of spherical cylindrical type of nanomaterials, and here we have polymeric material or block copolymers. So, both we can mixed up these two, and then we can get a composite. Okay. So, that nanocomposite is useful for a specific applications. So, I said in microbial fuel cells, they are in membranes also we can develop by this way. So, the polymer or nanocomposite materials, so that would be good for application of fuel cells or other places. Okay. So, here means many applications you can see. So, medical implants, wound healing, dental applications, bioimaging, biosensors, many places it has been used. So, here block copolymers, that is we can use with titanium oxide. So, that materials highly photocatalytic activity, that we can use. Conventional we use titanium films, but if we use titanium with that copolymers, so then that composite materials would give much more better results than conventionals. Titanium materials we use as a catalyst for catalytic reactions. So, then that would be give much more better results. Okay. So, these are the basic things or different places of applications of nanomaterials and its characterizations that we have discussed. Okay. So, in our next class, individual characterization techniques we will discuss more details and individual applications. So, with particular mechanisms, individual applications we will discuss more details. Okay. So, thank you. So, today is up to this. Thank you.